2.
Okay. So number 1 says, which diagram best represents all possible outcomes of rolling a number cube numbered 1 through 6 one time? So how many sides do we have? How many possibilities do we have? 6. So which of these tree diagrams shows you that? Yeah, it should just be D. Because there's 1, 2, 3, 4, 5, 6 sides. So 6 different options we could land on. On number 2, Manny and Kyle are playing a game. They toss a fair 6-sided number cube numbered 1 through 6. They spin a spinner, which is divided into 3 equal regions, 1 colored red, 1 colored green, and 1 colored blue. Which list shows all the possible outcomes of spinning the spinner and tossing the number cube? Yeah, so for each color we land on, we could land on one of the sides of the dice. So yeah, you'd have red, 1, 2, 3, 4, 5, 6, and then the same thing with green and the same thing with blue. So the only one that shows us that is D. Red 1, red 2, red 3, red 4, all the way to 6. Same thing with green all the way to 6 and blue all the way to 6.
But this one doesn't do.
Which one?
But it's just like...
Well, but it's giving you all 3 colors and the number 1. D is showing you that each roll and each spin. So like you could spin it, land on red, and land on the dice 1. You could land on red, dice 2. That's each individual option. Okay, number 3, 4 Miss Hopkins classes are going on a field trip. Each class has an equal number of boys and girls. Mrs. Lard is creating groups that have 1 student from each class by randomly selecting student names from a list. Which simulation can Mrs. Hopkins use to create the groups for field trips? So 4 of them. So A says flip 3 coins where head represents boys and tail represents girls. Well, if we flipped 3 coins, that would only represent 3 of the 4 classes. So A wouldn't work. We've got 4 classes. I don't know why we would use 3 coins.
Miss Ship, do you ever feel like...
Okay, B says select a marble 4 times, returning each marble after selection from a bag. The bag has an equal number of purple, green, red, and blue marbles where each color represents a class.
But you're putting it back.
But, well, yeah, first of all, we're putting it back. And second of all, we are trying to randomly select student names. We're not selecting the classes. We're selecting student names from it. So by having a different color for each class, that would be good, but it doesn't help us pick students out. Then C says roll 4 number cubes. So far so good because we've got 4 classes, where each cube is 1 class. The even numbers on the number cube represent a girl, and the odd number on the number cube represent a boy. That sounds pretty good because that's pretty fair. There's 4 cubes for 4 classes. Even numbers are girls, odd numbers are boys. That would be a good way to pick our classes. And then D, roll 4 number cubes where each cube is 1 class. The numbers 1 and 2 on the number cube represent a boy, and the numbers 3, 4, 5, and 6 on the number cube represent a girl. Yeah, what's wrong with that?
First of all, you continue selections for a girl.
Good.
And the other one is you're trying to pick one person out of the class, not the whole class.
So yeah, the main problem is that there's more numbers that represent girls than boys. So that wouldn't be a fair way to pick. So C is the only fair way we can choose that. Number 4, if Paul rolls a 6-sided number cube, a dice, numbered 1 through 6, 36 times, how many times should Paul expect to roll a number less than 3? So how many numbers are less than 3 on a regular number cube? 2. So 2 out of 6 on a normal number cube. Can I reduce that down? So it can be 1 over 3. And now we want to see if we roll it 36 times as our total, how many would be less than 3. So we can set up a proportion, we can cross multiply and divide. Basically 36 divided by 3.
12.
12. Number 5, Cindy wants to participate in an after-school program. She has a choice of 2 art classes, 3 dance, 2 gymnastics, or 3 sports classes. She cannot decide, so she writes the name of each class on a slip of paper and draws 1 slip out of a bag. What's the probability that she does not draw a dance class? So first thing, figure out how many total classes she has. How many is there?
She has 10.
Good. So 10 total. And now how many dance classes were there?
There were 3.
3. So we can subtract 10 minus 3. Good. So 7 over 10, and that's one of our answer choices. So we're good. Number 6, Julia spun a spinner 35 times. So that's our total number. The table below shows the number of times the arrow of the spinner landed on each of the 6 colored sections. So Julia wants to predict how many times the spinner will land on yellow if she spins the spinner 50 times. Which of the following correctly explains Julia's prediction? So this table shows us 35 total. So 35 times. How many times did she land on yellow in this table?
14.
So 14. But she wants to see out of 50 times, how many would they land? How many times would they land on yellow?
It would be. You cross multiply.
You cross multiply and divide, and you can actually cross.
Okay.
Okay, so 700 divided by 35 should be 20. So then your answer should be B.
Yeah, that's what
On number 7, Samuel rolls a fair 6-sided number cube numbered 1 through 6 and records the results. Which statement about this experiment is true? So A says he is more likely to roll an even number than an odd number.
No.
What's wrong with that?
Because it's even between them.
It would be even between them. Yeah, there would be 3 even numbers, 3 out of 6, and 3 odd numbers, 3 out of 6. So we're looking for one that's true, so A would not be true. B, it says he is more likely to roll a number greater than 4 than an odd number.
Nope. No.
So how many numbers greater than 4 on a 6-sided dice?
2.
2 out of 6, and how many odd numbers are there?
2. No.
1, 3, 5?
3. Yeah, but.
1, 3, and 5 on a 6-sided dice.
Oh, yeah, sorry.
So that would be 3 out of 6. So he is not more likely to roll a number greater than 4. He's more likely to roll an odd number. So B would not be true. C, he is more likely to roll a prime number. Remember, prime numbers are 2, 3, 5, and 7 for a 6-sided dice.
7.
Oh, 2, 3, 5, sorry. 7's not on a dice. And then a composite number would be 4 and 6. We don't count 1 for either of those. So is that true? Is he more likely to roll a prime number than a composite? Looks good so far. We'll put a star.
And then he's more likely to roll a number greater than 5 than any even number. That's fine.
That's not true. If a number greater than 5, that would just be 1 over 6, and an even number would be 3 out of 6.
I like your star.
Thanks. It's like a blob. Like a blob of a star. So C should be our answer.
That star must have